Alright, so now let's go into some analysis of how to actually do some calculations with these. So there's a process called sign analysis, not sign like sine cosine, but sign as in stop sign. So sign analysis, this is a way of testing your critical points, okay? Testing critical points. Alright, so some people call this the first derivative test. I like sign analysis because that sounds pretty cool and scientific. But anyways, so the whole concept behind this is that instead of like we were doing before, when we would find a critical point, we would just kind of plug those along with our endpoints into the original function and then just compare the values that we got. But instead of doing that, we can be a little more professional about it and academic, and what we're going to do is use the first derivative instead. Okay, so what we're going to do is, like I said, we're going to use the first derivative. This uses the first derivative, hence some people call it the first derivative test. Okay, and what we're going to do is we're going to look for a sign change. Well, first of all, we're going to analyze what's happening, what the sign of the first derivative is on certain intervals, and then we're also going to look for a sign change, which indicates or shows local extrema. Okay, extrema, and again, extrema means minimum or maximum. Okay, so what that means is if we have, let's say, for example. So if our f prime of x, if our first derivative were to change from being positive, and then it goes to 0, and then it switches over to become negative, what does that mean? So if we have that, then that means that our when it's positive, that means the slope of the tangent line is positive. Okay, it's positive, it's still positive, and then it goes to 0. Bam. Here's 0. There's the tangent line. It has a slope of 0. So this means we're at a critical point, and then it starts switching to be negative. Okay, so now we have this negative slope. So what I'm kind of sketching here is like a downward shaped U, right? So this means that at this point here, at the little arrow there, when f prime of x is equal to 0 at our critical point, that means that we're at a maximum. Okay, so a maximum or local maximum here. This is when the first derivative changes from the positive sign to a negative sign. Okay, let's examine the other case. So if our f prime of x switches from negative to becoming positive as it passes through 0 or undefined or does not exist, right? Then what we'll have is we started off with negative slope, right, of the tangent line. So negative slope, negative slope. Okay, that was a really bad line. Hold on. Negative slope, negative slope, negative, negative, still negative. But then at some point it hits 0, right? So here it's 0. The slope of the tangent line is 0, so f prime of x is 0. We're at a critical point here, and then it turns out to be positive as we keep going, as we continue. So then it's positive, 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 and at this point we're drawing an upwards U, right? So an upwards U, and so this therefore is a local minimum. Okay, so we just found out that a minimum occurs when our first derivative changes signs from negative to being positive. Okay. And now let's see, so how about another case? So if f prime of x changes, or if it goes from being negative, and then it turns into 0 at some point, or undefined, and then it continues being negative, what does this mean? So what this would mean is that we have a negative slope, okay? So we're going along, we have a negative slope, negative slope, negative slope, and then at one point it's 0, okay? So this is a critical point still, right? If our f prime of x is equal to 0, but then it just continues being negative, negative, and it keeps going along, right? So here what we see is kind of like an S graph, right? That's what happens when we have an S graph, such as negative x to the third power. And see here in the middle, we do have a critical point because our first derivative is 0, but we don't have a local maximum or minimum. We just kind of keep going downward. So this is neither. Neither happens here. So neither max nor min. Okay, so let's examine the other one. We'll just see if our f prime of x goes from being positive to 0 to being positive again. What does that mean? So we have positive slope, positive, 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 but then it becomes 0 eventually. Okay, so here's 0. All right, so this is a critical point, but then it just continues going up, being positive again. Okay, so then that kind of gives us another looking like S thing. Okay, so let's say that was actually kind of bad, but we had this S, and then it levels off and keeps going up. So here the first derivative might be 0, but it doesn't really matter because our first derivative keeps staying positive, so that doesn't really matter. Okay, so this is also neither a max nor min. So what we've learned from the past couple slides is basically that when our f prime of x, when f prime of x changes from being positive to negative, that means we're going from an upward increasing to a decreasing, right? At this point, that means we're at a local maximum, okay? And if it switches from being negative to being positive, then that means we're going from decreasing to increasing. So that means we're at a local minimum, at least, okay? Let me love you.